Hello everyone. Our project title is comparison of composite monolising with conventional shipping using CAE tool. You are using two softwares for analysis of composite monolising. One is SolidWorks, another one is ANSYS Workbench. We have used SolidWorks for drawing a surface modeling of the monolising. Why you use surface modeling? Because it has zero thickness. We have add thickness in ACP tool in ANSYS Workbench. We first of all we draw a line, then create a monolith spring. It have zero thickness. It width only it will be measured. After creating a surface modeling of the monolith spring, using a ACP tool. ACP tool means Advanced Composite Prepost, or used to measure the thickness and layers to be added in the composite material. This is a model of the monolith. The model has 8 layers. First layer and last layer of E-glass fibre. Then between Aloevera and Roselle are 6 layers. The apex resin is added between the layers of the. It's act as a gum to use to create a composite material. Normally, the vehicles use carbon steel at the leaf spring. We have identified load at varying load at carbon steels and e-glass fibers. Then we have got to composite materials. This is a deflection range of 2000 Newton at the carbon steels. This is a reading of the carbon steels. Then carbon steel at 4000, 6000. This is a composite material of model analysis. Model analysis shows the frequencies of the composite materials. Um, Natural frequency are compared to the other materials, then we can find and identify the strength of the leaf spring materials with compare of composite materials to the other two materials of the carbon steels and e-glass fibers. This is a reading of model analysis shows the frequency range of the composite materials. Then we have go to the composite material at varying loads. This is a composite material at 4000 Newton. This is a reading of the 4000 load at monolith spring of composite material. This is materials, various materials, 8 layers of the composite materials. A-glass fibers, Roselle and Aloevera. Between the apex regions extra. Then we have go to the deflection range. It will be uh, minimum of saying compared to other two materials. It is a minimum. It is no high deflection. It is deflection ranges becomes low. um, this indicates the deflection range is maximum. That will indicates red color, but it does not shows the red color. So the deflection range becomes very low compared to other materials. This one becomes carbon steel's natural frequencies range. It shows the deflection range and natural frequency ranges. Then we go to the glass fiber at 4000 Newton, load at 4000 Newton. This is a deflection range of glass fiber. The deflection range is maximum at indicates it's compared to composites will strength becomes low. To compare the composite material, this is a reading of the composite material loaded 4000 Newton. To compare the composite material, its composite material deflection range becomes low compared to the glass fibers. Deflection range becomes low. Uh, the deflection range becomes high, and it will break at high tension. But the range of deflection ranges becomes low when compared to other materials of other materials. In composite materials low. This is a reading of carbon steels readings. It's the deflection range, not the deflection ranges compared to composite materials. Then the report will shows the comparison of the impact load and the free natural frequency of the different materials. Our project members are Vignesh, G. Balaji, and Austragiri, and myself, G. Radish. Our project based on the leaf spring plays a virtual role suspension system widely used in the heavy commercial vehicles. So it is used to withstand vibration, absorbing energy while the typical road condition. The scope of these papers analyzes the dynamic characteristics of the composite leaf spring. A combination of 8 layers. That means create a composite like Aloevera E-glass fiber with e-packaging to create 8 layers of composite. impact reduction will be added between the gaps. And alternative conventional plain carbon steels are respect to reduce the weight of the increasing the stiffness. Then the ultimate aim to analyze the explicit dynamics of model, dynamic and model properties of composite spring, different load condition, and impact resistance of the load. Then we have used Zydox and ANSYS workbench. Then the result of simulation analysis is used to compare the dynamic characteristics of the composite. Let's bring compare the materials or plain carbon in A-glass fibers at different load conditions. Concludes like maximum load that the composite of the leaf spring can withstand and the fatigue life of the both steel and composite leaf spring is compared using ANSYS software. This is analysis results of the carbonaceous E-glass fiber and composites. This deflection range will be shown in the figures, and then the table diagram is contains a deflection range between the three materials to compare this the deflection range. And in final, we have comparison discuss about the explicit dynamic analysis of comparison of composite materials, E-glass fibers, and plain materials, and the deformation at various loads. Comparison of model and harmonic analysis of plain carbon steels and E-glass fibers, and another one is composite materials. From the above comparison, we can see the composite made of observed Aloevera, Roselle and E-glass fibers has less deflection compared to the plain carbon steel and E-glass fibers. It indicates the deformation is highly controlled in composite spring after applying 8000 load. Thus, we have see the possibilities of the resonance in the highly reduced our composite leaf springs. And then we have conclusion. From above comparison, we have seen that the composite material produces the less deformation of 0.3445 mm even 8000 Newton. So the composite material is the best one. My project.